Let's talk about global shipping. I mean, it's this massive, multi-trillion-dollar system, basically the invisible engine that moves almost everything you own. But that engine is about to get a huge, mandatory, planet-sized overhaul.
Just think about it. Nearly everything you own at some point was on one of these ships. For decades, they've just been chugging along on heavy fossil fuels. But that's all changing. The clock is ticking, and international maritime law is demanding a radical shift. And, this isn't just a friendly suggestion, it's a hard requirement.
So, what's the big push? Well, it's all about a new green mandate. The entire industry, this multi-trillion-dollar behemoth, is being forced to take a hard look at its environmental footprint. And it's all because of a brand new set of international rules they simply can't ignore.
Okay, so here's the core of it, right? From the International Maritime Organization. They're calling for a 40% cut in carbon intensity by 2030. Now, carbon intensity isn't just about total pollution. It's really a measure of efficiency, like how much CO2 does it take to move 1 ton of cargo 1 mile? And slashing that by 40%? Wow, that is a massive, massive task for an industry that hasn't really changed how it powers its ships in, like, a century.
So how in the world do you enforce something like this? Well, with something called the Carbon Intensity Indicator, or CII. And honestly, the easiest way to think about it is like an annual report card for pollution. Every single ship gets a grade, from A to E, on its carbon efficiency. It's a really simple but powerful way to make a super complex problem totally transparent.
And this isn't a one-and-done kind of thing. It's a constant cycle. Ship owners have to calculate their efficiency, report their emissions, get that A to E grade, and if they get a D for 3 years in a row, or even a single E, they have to create a whole corrective action plan. And believe me, this has real teeth. A bad grade could mean higher insurance costs, getting blacklisted by clients who care about this stuff, or even being denied entry into major ports. Basically, there's no hiding from the data anymore.
So with all this pressure to decarbonize, the industry is scrambling for a solution. And right now, the leading contender to replace those old, dirty diesel engines is a technology you're probably holding in your hand or have in your pocket right now, the lithium-ion battery.
And the advantages? They're pretty incredible. First off, and this is the big one, 0 direct emissions when this ship is running. That right there is a total game changer for hitting those new targets. But it's not just about the environment, it's also about money. You're talking about no more expensive, super volatile fuel costs, way less maintenance, and a much more reliable source of power.
I mean, just look at this side by side. It lays it all out pretty clearly. When you look at emissions, fuel costs, maintenance, the lithium-ion system just crushes the traditional engine. It really makes the switch to electric seem like a complete no-brainer, right?
Which, of course, brings us to the million-dollar question. If this technology is so obviously superior, why isn't the entire ocean already filled with electric ships? Well, it turns out there's a catch, and it's a pretty big one. Right, so this is where the story takes a bit of a turn. That electric dream, it comes with some hidden and pretty serious risks. And for a ship out in the middle of nowhere, those risks can be, well, catastrophic. The #1 safety issue is this really terrifying thing called thermal runaway. You can think of it like a line of dominoes. If just one battery cell overheats or gets damaged, it can set off a chain reaction in the cells next to it, releasing this intense heat and flammable gas. And that can lead to fires that are just incredibly difficult, if not impossible, to put out, especially when you're all alone in the middle of the ocean.
And here's the tricky part. Not all lithium-ion batteries are the same. As you can see here, there's this direct trade-off. The safest type, LFP, it has a really high trigger point for that thermal runaway. But the batteries with the highest energy, the ones you'd want for a really long trip, they can go into that dangerous state at a much, much lower temperature. So it's this constant battle between performance and safety.
And beyond the immediate safety risks, there's the bigger environmental picture. Sure, the battery is 0 emission while it's being used on the ship, but its full life cycle tells a totally different story. You got the mining for raw materials like lithium and cobalt, the super energy-intensive manufacturing process, and then the problem of what to do with them at the end of their life. You can't just ignore those impacts.
And finally, we just run into the simple physics of the whole thing. The lithium-ion batteries we have today are already getting pretty close to their theoretical limits for how much energy they can store. For a truly massive cargo ship, you need a battery system that is so huge and so heavy that it could actually mess with the ship's stability and how it handles in the water. We're kind of hitting a wall with the current tech.
Okay, so if today's batteries aren't quite the silver bullet, what's next? Where do we go from here?
Well, the future of ship power might just lie in a brand new technology that promises to solve a lot of these problems, the solid-state battery.
So what's the big deal with solid state? Here's the key difference. A regular lithium-ion battery uses a flammable liquid to move energy around. A solid-state battery, like the name says, uses a solid material instead. And that one simple change makes them way safer, much more stable, and it opens up the potential for way higher energy density. And just look at this chart. This shows the leap in energy density we're talking about. Solid-state batteries have the potential to pack significantly more power into the same amount of weight, and that is exactly the kind of breakthrough the shipping industry needs to get past those weight and space problems on these huge ocean-going vessels.
But we have to be realistic here. This tech isn't quite ready for prime time yet. I mean, the first viable materials were discovered over a decade ago, but going from a small lab to full-scale industrial production, that is a huge engineering hurdle. You've got big players like Toyota planning to start production for cars around 2028. But for the massive scale that shipping requires, we're probably looking at sometime after 2030 before it's a reality.
And that brings us to a really interesting final thought. This incredible pressure to clean up global shipping is basically force-feeding R&D for these next-generation batteries. So the question is, could the exact same technology that will one day power these giant cargo ships across the ocean also be the key that revolutionizes the electric car sitting in your own driveway? It's a pretty fascinating thing to think about, isn't it?